Welcome back, guys. As previously mentioned in the video before this, I promised to run through an example or two. So in this video I'll be running through one example, and in the next video I'll be running through a second example. Here we have a simply supported beam with a pin at this end and a roller at that end. Length is 10 meters and we have a negative clockwise moment 4 meters from this edge, the left edge. So what do? We start off by saying step one is drawing the reaction forces on the free body diagram. So if we just look here, drawing the reaction forces on the free body diagram. Okay, so first of all, we've got a pin on the left hand side, so we know that we have a vertical restraint, which is VA. We have a horizontal restraint, HA. And finally we have a vertical restraint at the pin only, one vertical restraint, VB. Second of all, step number 2 is establishing equilibrium. So we just write that down. Sorry. Establishing equilibrium. So first of all, sum of these forces in the x direction must equal to 0. Looking at the diagram, HA is the only horizontal force, so immediately we know that HA is equal to 0 kilonewtons. Second of all, we know that the sum of the forces in the y direction must equal to 0, so sigma Fy equals to 0. Now we have two vertical forces, so VA plus VV equals to 0 kilonewtons. We have two unknowns, so we need to incorporate the sum of the moments to work out VA and VB. So what we do is we're going to do the sum of the moments about this point, so I'm going to call that A, must equal to 0, so I'll just jot that down quickly. So sum of moments about A equals 0. So first of all we have minus 10, which is the clockwise moment here. Notice that VA and HA have no moment about A, obviously because there's no lever arm. VB creates an anti-clockwise moment about point A. Remember, finger on point A, rotate in the direction of VB. The paper is moving in the anti-clockwise direction, indicating a positive moment. So we do plus VB times the perpendicular distance, which is this distance to that, which is 10, equals 0. So solving, we get VB equals to 1 kilonewton. Up here I indicated that the sum of the forces VA plus VB is equal to 0. Since VB is equal to 1, so VA plus 1 equals to 0. Solving this, we find that VA equals minus 1 kilonewton. Nice and easy, just the use of equilibrium. Finally, we just establish our solution. We found that VA equals minus 1 kilonewton, VB equals 1 kilonewton, and finally HA equals to 0 kilonewtons. Just to start off again, this is our diagram here. We have a pin, so we have we have one vertical restraint and one horizontal restraint. We've got a roller here, so we have one vertical restraint, and we have an external moment, 10 kilonewton meters. So step 1 was drawing the reaction forces on the free body diagram, which were the restraints, the blue ones. Step 2 was establishing equilibrium, so sum of the moments in the x direction is 0, HA equals 0 immediately, as it's the only horizontal force. Secondly, we had the sum of the forces in the y direction equals 0. So VA plus VB equals to 0 kilonewtons. Since we had two unknowns, we had to take into account the sum of the moments about point A, this one over here, which equals to 0. So it was minus 10, which is the negative clockwise moment, plus VB times 10 to 0. From there we solved that VB is equal to 1, and then we found that VA equals to minus 1, in which we established our solution. Okay guys, that's the first example. I'll be running through the second example in the next video. Thank you for listening.